Hi, welcome back to our series on working with newtons as a unit and what happens with a compound unit as you expand it out and have to cancel. And that's the subject of today's of this video, is to look at what happens when we want to calculate mass and acceleration out of Newton's second law. So let's get started. First thing we need, of course, is our power circle, and our power circle is force, mass, and acceleration. And as I suggested in the previous video, I would suggest that you place your units on the power circle or just off the power circle, just as a reminder, at least until you get used to using them. So force is measured in newtons, mass is measured in kilograms, acceleration is measured in meters per second squared. The other thing we're going to be using today is our equality that we set up in a previous video, that 1 newton is 1 kilogram times a meter per second squared. And we'll be using that quite a bit. To start off today, we're going to start with an example of some guys who built a hoverboard. And we're going to watch this. Please watch with me as we watch this, and we'll pull out a problem from it.
The air cushion provided by the blower lifts the heavy plywood board and 100 kilograms of Johnny off the ground with ease.
Right, I'm going to give you a push and let you go, yeah? Go!
And because there's very little contact with the floor, there's very little friction, which means all you need to do is apply a tiny force to go flying.
Johnny, it's working a treat!
Hoverboards are fairly easy to build and a lot of fun.
Now, having a ride height of just a few centimeters means it wouldn't be very good on rough ground, but on a smooth, polished gym floor, our do-it-yourself hovercraft is definitely a success.
And as they said, we're going to eliminate friction. That's one of the reasons we pulled this out. So let's take a look at what it looks like, a sample problem would look like. So first problem, how quickly could you accelerate Johnny and the hoverboard if together they had a mass of 110 kilograms, again here I'm estimating, and you applied 200 newtons of force? Well, the first thing we do when we work problems like this, no different from other problems, is we set up our given statement. What are we given? And we know kilograms measures mass. It's also told us right here in the problem that this is mass, and so we write mass as 110 kilograms. Newtons is our unit of force, so 200 newtons must be our force value, other than saying it right here in the problem. And so again, these are estimate values. I don't know exactly how much their hoverboard weighs, or the mass of their hoverboard, sorry. So let's go to our problem where we have mass, we have force, we look at our power circle, we're obviously missing acceleration, and that's what our problem tells us to find. And so we're going to bring our acceleration down and put an equal sign next to it, and then we take it out of the power circle. Cover that up with your thumb or your finger, and what's left in our power circle is force on the top and mass on the bottom. And so we're going to bring our force down, and we're going to put it on the top. We're going to bring our division bar down, we're going to put it right underneath force, and then we're going to bring our mass down here, and we're going to put it right underneath our force. And so we have acceleration equals force divided by mass for our formula. Again, no friction here, so we don't have to account for a net force. It's just the force applied. So then we continue with our setup, and to continue our setup we need to bring in our acceleration. And then what we're going to do is we're going to substitute the value that we have for force and the value that we have for mass in for our setup. And so our 200 newtons goes on the top, right into that force slot. Our mass of 110 kilograms will go in right underneath after we put our division bar in. Okay, and so we have acceleration equals 200 newtons divided by 110 kilograms. At the face, it doesn't look like there's going to be any cancellation, but here's where you have to remember that a newton is a kilogram times a meter per second squared. And so what we're going to do here is we're just going to substitute. We're just going to slip that value in. Now, by the way, if 1 newton is 1 kilogram meters per second squared, then 200 newtons is 200 kilograms times meters per second squared. It's that easy. So we slide our equal sign over here. We're going to slide our 200 over, and we're just going to expand that newton unit out to kilogram meters per second squared. Same thing on the top here. We're going to bring our division bar in. We're going to bring our mass value over. And so the only thing here that we're changing is just to see what's inside of that newton. And when you see what's inside of the newton, it becomes obvious that we have a cancellation. And so since we have kilograms in the top and in the bottom, we cancel them out. The only unit that's left is meters per second squared. So when we calculate our acceleration, of course, is 200 divided by 110, which comes out to 1.81. The only unit we have left to put in there is meters per second squared. And so that is our value. Okay, so that's an example of calculating acceleration. Let's go on and take a look at an example of calculating mass. This example is of a gentleman who's going to push his son on his bike. And so let's watch the video and we'll pull out a problem from that. There's the push. Oh! Aha, he
But
missed the
that
pull.
was really good, though.
He's still flamed out. So let's take a look at a sample problem you might see on a quiz or a test from that. So here we go. Find the mass of the boy on the bike if the dad pushed with a force of 100 newtons. And he accelerated, that being the boy, accelerated at 4 meters per second squared. Now, we'll start with our given values. And our given value is 100 newtons here. We, of course, know that newtons measures force. And so let's pull that down and put that into our given. And he accelerated at 4 meters per second squared. Meters per second squared, of course, is the unit for acceleration. And so we'll pull that one out. We'll put that into our given statement right here. So there are our givens. We then go for our formula. Of course, what's missing here is our mass. We've got our force and our acceleration. And the problem does say find the mass of the boy. So we take our variable m equals, put it in here, and then put your thumb or your finger over the m in the formula to cover it up to give you the remainder of the formula. And you can see what's left is force is on the top and acceleration is on the bottom. So we're going to write that for our formula. So we're going to bring our force down. We, of course, need our divide bar, division bar, and acceleration slips in underneath the division bar. So it's mass equals force divided by acceleration. So then we go to our setup, and in our setup we're simply going to substitute. So again, we start with our mass equals, now we substitute our force value in, 100 newtons, we're going to slip that right into the force. Our division bar comes in, and then our acceleration value of 4 meters per second squared slips in here underneath the force. And again, at first blush, it looks like nothing's going to happen. We don't have any units here. But we do know that newtons, units that are going to cancel, but we do know that newtons is a compound unit and we can expand it out. And so we bring our equal sign over, again 100 newtons, since 1 newton equals 1 kilogram meters per second squared, 100 newtons will equal 100 kilogram meters per second squared. So we just bring our number over and we expand our unit out so that these are the same values here, same measurements. We bring in our division bar and then we slide our acceleration value over underneath. Now you can see that the acceleration units, we have acceleration units in both the top and the bottom. Those are going to cancel out. We're going to be left with kilograms, and that's exactly what we need to measure mass. So these things all work out if you expand the units and do the cancellation. Of course, when we calculate our mass, our number is 100 divided by 4, and so that works out easily. That's 25. Our unit is kilograms, so right from here we put in kilograms, and that is our value for mass. So I hope this helps in working with mass and acceleration calculations in Newton's second law in the next set of exercises that you're going to do. So thank you and have a great day.